This is our transmitter for our project number 2 for circuits 2001. Nice. So first we start off with the mic side where we have our power, 4.5 volts. That's split from the battery going through a resistor and our mic, which connects to the ground. And then it goes through a high pass filter of a capacitor and resistor, which blocks DC current, as well as filtering out certain frequencies that we don't want. And the DC current is coming from the 4.5 volts to power the mic. Then we have it hooked up to a potentiometer, and what that does is that it allows it to adjust the volume to whatever we want, all the way up to 0. And that goes through an amplifier, which increases the voltage going through so we can hear it more likely. Because we have both a mic and an aux going together, both providing AC signals, and while the mic only comes in at around 30 millivolts and the aux comes in around 1 volt, we want them both to be the same as each other so one doesn't drown the other out. So that's why we use these 2 op amps. This is one right here is the aux one to make sure they're the same. Then from our aux, we have our aux connected straight to ground into our potentiometer, which also adjusts the volume, into the op amp I was just talking about, and then another capacitor block the DC coming through. Then we have our summing amp, which basically amplifies the signal as it goes through the AC signal as it goes through the laser, with these 2 resistors that increase the voltage on a gain factor. Since it's 101, the gain factor is times 100, so it multiplies it by 100. And that goes through a capacitor, which blocks DC, because this is our negative offset, which powers the laser so that it shoots a continuous beam, and then it mixes with our AC signal coming from our summing amp, which comes from our op amp and our mic, to create a nice signal that is both on and has AC at the same time. And we wouldn't want this DC signal to go back into the op. And how we achieve this is through a voltage divider of the battery. So basically what this is that this is your power source, your battery, and then you have op amp connected to ground between 2 resistors that need to be equal value, and then it just splits the voltage in half with the ground at the very end.
Okay, so this is our receiving circuit. The input comes in through the solar panel here, and it's about 1 volt AC and 5 volts DC. And then it's filtered through the high pass filter, which we decided to filter out anything less than 500 hertz. So the resistance and capacitance values were determined through this equation. And then it's filtered through the op amp with a potentiometer that's connected to ground, which is able to turn on and off the speaker. And then this signal is filtered through the speaker, which is also grounded, and plays about 4 volts.
Tell me one. So here's our board, and I'm gonna have Wally explain the sources of error.
So with the board saying, one of our problems was we couldn't find a battery with a high enough voltage charge. They were around like 5, so we had to find a new battery. It was a hassle, I tell you what. People didn't want to give up their batteries. People were fighting over them. We used like 4. It was rough. And then we had this capacitor in the board over here because that reduces the noise in the board. It makes our speaker quieter and less noise. Great. And then one of our problems was our LED was too low. So what we did is I don't know, what the fuck do we do?